Hello, I am Flash Isaac. This is Flashlearners. You are now watching 120 Days to Jamb. This is a series containing 120 videos to prepare you for Jamb. Each episode of the series contains introduction, outline, detailed class, questions, and homework for you. The questions and homework are from the Flashlearners Jamb application. Install Flashlearners Jamb app today to access all the free features. Click activate and scroll to buy activation key to get access to the golden features. Don't be scared, the app is affordable. Do you have trust issues? Simply chat me directly on Facebook, WhatsApp, Instagram, and Telegram for installation and activation instruction. Ladies and gentlemen, it is time to take off. This is episode number 7 of the 120 Days to Jamb Physics with Flash Isaac. In episode 6, we introduced measurements and units, and we discussed all this, obviously in a very quick manner. Our mass is kilogram, and we can measure mass using beam balance. The unit time is measured in seconds, milliseconds, or other smaller units. While the measuring devices for time are stopwatch, stop clock, pendulum, and so many devices like we use at home and around. Then we talked about fundamental and derived quantities, dimensions, accuracy, errors, standard form, and significant figures will come under questions. But let's see something. If I say 20000000, the more the zeros, the more the space it occupies. I can decide to say 2 times, how many zeros do we have? 6 times 10 to the power of 6. I've represented this value in standard form. If I say 0.00000002, I look at this. This is occupying a lot of space. Can't I simplify it? You can do it this way. There is decimal point here. You start moving. 1, 2, 3, 4, 5, 6, 7. You move 7 times before you go to the end of 2. This will give you 2 times 10 to the power of minus 7 to show that it's a decimal point and you move this way. For this, the decimal point is at the end, so you move to your left. If I do something like this, 0.0201367891, and I say, this is too much. Why can't we reduce it? Round this off to 3 significant figures. 3 significant figures. You simply say 0.0201. Why? The first significant figure is the first value after the decimal point that is not 0. So the first value here is 0. So this is not the first significant figure. The first significant figure is 2. Now, after you've gotten the first significant figure, any number that comes after the first significant figure, whether it is 0 or a meaningful number, this is the second, this is the third, and many more. That is the concept of standard form and significant figures. Then I told you that we have 7 main fundamental quantities. Any other quantities in physics apart from these are derived. Example, force, acceleration, momentum, velocity. All these are derived quantities. To get the dimension of derived quantities or their formulas, you need to know the definitions and what they are made up of. If I say, what is force? Force. You tell me that force is mass times acceleration. If I say, what is velocity? You tell me displacement over time. When you differentiate displacement, you get as a velocity. Now, what is displacement? Displacement speaks of distance, the ground covered by an object, like the difference between the starting point of an object to the ending point of an object. That is displacement, the distance covered in a specified direction. And talking about distance, distance speaks of length. Distance, space, length, that is about length, which means this is like saying length over time. What is length? Fundamental quantity. What is time? Fundamental quantity. What is the dimension for length? L. What is the dimension for time? T. So the dimension for velocity is L over T, which is the same thing as L divided by T, which is the same thing as L T raised to the power of minus 1. If I say 2 over T, division, to change this or to bring this up, it is the same thing as saying 2 T raised to the power of minus 1. 2 over T squared is the same thing as 2 T raised to the power of minus 2. So when you bring denominator up, it becomes negative. So talking about the concept of dimension, that is the dimension for velocity. Dimension for temperature is K, electric current is A, amp, luminous intensity CD, that's candela, is the dimension, and amount of substance is MOL. Once you get definitions, you simplify the definition, let them be in fundamental quantities, put the dimension of each of the fundamental quantities, you will get an answer. So from now, we shall be solving questions under physical quantities to cover all these aspects, and we will explain so that you get the details. No stone is supposed to be left unturned. Which of the following dimensions represents impulse? Impulse. What is impulse? Impulse is change in momentum. Change in momentum is impulse. And what is change in momentum? Change in momentum is force times time. From Newton's second law of motion, the rate of change of momentum of a body is proportional to the force applied. And change in momentum is final momentum minus initial momentum over time. That is change in momentum. mv is final momentum, mu is initial momentum. If I say you've changed, it simply means the new you minus the old you, or compared to the old you, over the time period. So you change over time. Since mass is the same everywhere, it is the quantity of matter in the body. It doesn't change, although weight changes up and down. We say force is mv minus u over time. mv minus u over time. Now, what is final velocity minus initial velocity over time? Or what is change in velocity over time? Change in velocity over time is acceleration, which means force is proportional to ma. And in this thing, we are taking the constant to be 1. So equals k, k is 1. From here, force is equals m over t, and force is equals ma. So this is where we derived force is equals ma from, which we use throughout physics. This is by the wayside. Now from here, when you cross multiply, force times time is equals mv minus u. Here is change in momentum, which is final momentum minus initial momentum. Change in momentum is equals force times time. So this force times time is referred to as impulse. Impulse is usually defined as a large force acting over a very, very short period of time. So add this to your dictionary. Impulse is force times time, which means that force is mass times acceleration. So this is mass times acceleration times time. This is impulse. Now we try to change everything, or to make everything become fundamental quantities so that we can use these units. Mass is fundamental, time is fundamental, but acceleration isn't. We break down. Impulse is mass times acceleration is change in velocity over time or velocity over time. So v over t times t. You look again, velocity is a derived quantity. It's not among this guy. So why do we make it among this guy? We break velocity down. Velocity is displacement over time. So this is m times displacement. You can say distance. Displacement is distance. You put it as s over time. This displacement over time is only for velocity. This time is here, so it remains times t. So everything here are fundamental because mass, distance, which is displacement, length, which is distance, which is length, time t, time t, time t. We simplify m times s over t divided by t. This is the same thing as this. Now let's change this division to multiplication. We will therefore have s over t times 1 over t. When you change division to multiplication, what is in the other part will invert, which means if I say s over t divided by 1 over t, if you change this to multiplication, it will be s over t times t over 1. So this is s times 1 is s, t times t is t squared. This is s over t squared. If you have any way to solve it, you get that. So s, that is distance over time squared times time. What is the dimension of mass? M times s is distance, which is length. So the dimension for length or distance is L over t is time. The dimension for time is capital T, time squared times time. This is simply m L t, m times L times t over time squared. This is equals m L. We have one time at the top, 2 at the bottom. So 1 cancels 1 from here. We are left with only 1 time. And remember what we learned. Once you have something at the bottom or t at the bottom, bringing it up, it becomes raised to the power of minus 1. So this is ml t raised to the power of minus 1. So that is kilogram meter per second. You see, from dimension, you arrive at units of quantities. So the units of impulse is kilogram, length is meter per second, kilogram meter per second. So this is the dimension, this is the unit. Let's see the option. Option B is the correct option, as you can see. Ladies and gentlemen, we have to end this class. See you in the next episode. And for your assignment, open the Flashlearners Jamb app, click on question search and enter dimensions. Play with the ones you can. The ones you cannot answer, let me know about them. And in the next episode, we shall be solving more of dimension questions and other parts of the class.